Welcome back to screening. In this next video, we're going to set up the whole idea of sensitivity and specificity. So in this particular case, I'm going to be drawing on a 2x2 table. A lot of people laugh about how a lot of epidemiology can be boiled down to a 2x2 table, and this is just one more example of that. And so here we have a 2x2 table, and in this case I'm going to draw it a specific way, and if you have a certain way that you always draw it, then I think that will help you keep from getting confused. So for example, I always put the screening test over here on the left hand side, and the what I call perfect knowledge. Or disease up here on the top. And specifically what I mean by this disease state is the whole idea of a detectable preclinical phase. Remember how up here we said for secondary prevention, this is a case where these people do not have symptoms. And so this whole idea of a preclinical phase means that we are in this phase of the disease that the person it's not clinical. In other words, they are not having symptoms, but it's at a point where we could detect it with this particular screening test. So a detectable preclinical phase of that particular disease means that we have the option of doing this whole screening test. So when I say disease, a lot of times people are like, oh, okay, well, what exactly does that mean? Does that mean that they have their end-stage cancer? No, we're in this detectable preclinical phase area when we're talking about this. And what I mean by perfect knowledge is that if we were to know for sure if that person has the disease or not, in future videos I'll show you why sometimes that's difficult. But for now, just say, okay, if we had the perfect test that always was right, then what would we know about that particular disease for that specific person? So here's our whether the person has the disease, yes or no. And the screening test, here's where the person had a screening test that was positive. Sometimes we put parentheses around it. And here's the person who had a screening test that was negative. And so we have all of these different options. And the whole idea of sensitivity and specificity goes back to the idea that we want to have, and I'm going to have to scroll down here just a little bit. Sorry. Let's get ourselves some space. We want our results to be what are called valid. And by valid, what I mean is this whole idea of, oh, you're right, that was correct. And so let me give you two scenarios where the results were valid or correct. If a person has disease, so I'll put with disease, we think that that person should have a positive screening test. And a person without disease, that person should have a negative screening test. And some people would say, oh, well, that's really obvious, but I'm going to build on those two concepts. So I'm going to have to get rid of a little bit of our top part here because I need some space underneath. But so it seems obvious that the person with disease should have a positive screening test and the person without disease should have a negative screening test, but that's not always the case. So let's look at a case where it is. So let's say we have perfect knowledge, and we're going to just say that we have 100 people with disease, and so here's our yes disease, and this is the marginal total down here, and we have 100 people without disease, and so these are the no's. This column over here on the right hand side is no's. So if a person has the disease, and this actually works, all the people with disease screened positive, they would all end up in this top left box. So all the yeses had a positive screening test. Similarly, all of the people without disease, all 100 of them, would end up in this bottom box right here. So all of the no's would have a negative test. What we know about this, let me see if I can get rid of some of these lines. Oops, we'll put that back. What we know is that sometimes not all of the people end up in the right box. Sometimes the people who do have disease end up in this box down here on the bottom left. And some people without disease end up in this top box right here. So I'm going to change the numbers just a little bit. Let's say that instead of all 100 ending up here, only 90 of the people with disease had a positive screening test. What that means is that 10 people who have disease ended up with a negative screening test. And then for that same exact scenario, let's just say that of the 100 people without disease, 95 of them had a negative screening test, and 5 of them had a positive screening test. So I'm trying to do this so that they have a little bit different numbers and you don't get confused. So not all of them ended up being correct. Of the people who have disease, most of them ended up with a positive screening test, but a few of them ended up with a negative screening test. And for some of the people without disease, most of them ended up with a negative screening test, but a few of them ended up with a positive screening test. So this whole concept of validity or accuracy means that what we're trying to do is we're trying to find a test that most of the time gives us the right answer. So that whole idea of, oh my goodness, you're right. We want a test that is right. And so what we do is we end up calculating something called sensitivity and specificity. Here we have a bunch of people who, yes, have disease, and we want to know how sensitive is the test to pick up on people with the disease. And so what percentage of the time is the test correct? So sensitivity, let me see where I can write this, is the amount of time, let's scoot over here just a little bit. Sensitivity is the amount of the time that of those people with disease, how many of them had a positive screening test? And so here we have, of the people with disease, in this particular example, we have 100, and we had 90 with a positive screening test. So what that means is that our sensitivity is equal to 90%. And that's good. We want to pick up on the people with disease. We want our test to be sensitive to those who have the disease. And then we'll move on to the next test, which is specificity. Can't spell here. SPEC for short, specificity. And what that means is of those without disease, how many of them had a negative screening test? And in our specific case, here we have 100 people without disease, and 95% of the time we were right. So 95 out of 100 is 95%. So this test, if this was a hypothetical test, this would have 90% sensitivity and 95% specificity. In other words, if you don't have the disease, how specific is the test to make sure that you had a negative screening test? And so what we're doing is we're saying that if we call these two things over here the without disease and the with disease are denominators, how good is the test at being sensitive to pick up the ones that do have disease correctly, and how specific is it to not pick up those as positives who do not have the disease. So those are the two sensitivity and specificity tests for a screening test. So that's how we calculate them. We use the marginal totals here in the columns, and this points out the importance of setting your table up in a specific way. If we happen to trade the screening, not that far, trade the screening test and this whether they have disease or not, if we traded the rows and columns, then these marginal totals would no longer be on the bottom of the table. And so that's why I want you to learn what actually the table means and what sensitivity and specificity really mean, rather than just memorizing A over A plus whatever. Because I think a lot of times people try to do that and then they lose track. So be sure and understand what those mean, so that you can also understand that language, but be sure and always come back to this idea that of the people without disease or of the people with disease, how good is the test at being correct? So we want to be right most of the time.